Hi everybody, and please say cheese! Welcome to our presentation on what your Instagram profile reveals about you, predicting user attributes from following behavior. Social media is an ambivalent topic. On the one hand, there are many positive aspects we wouldn't want to miss out today. The rise of social media platforms led to and enhanced social movements and enables us to connect with the whole world. Social networks are messing up autocrats' plans. Black Lives Matter, from social media post to global movement. How the Ice Bucket Challenge led to an ALS research breakthrough. I found my baby sister on Facebook, 40 years after tragedy tore us apart. But on the other hand, especially in recent years, critical voices on the use of social media and associated data privacy concerns, even raised within the industry itself, get louder. Phone addiction. 4 in 10 university students so hooked they can't sleep. How Trump consultants exploited the Facebook data of millions. Clubhouse, the hot new social network, has big privacy problems. Your app knows you got your period. Guess who it told? Actually, the critical voices became so loud that even Netflix made a film about it. Nevertheless, most users still believe that their data is safe, as they do not post any sensible data on their social accounts. But is this true? Your Instagram profile may not contain any personal information. No profile photo, no biography, and no posts. However, your followings are publicly available. Taking a closer look at your following behavior, we know that you're likely to be female, have children, are in a relationship, and older than 19 years. This might be surprising for some of you. Now we will explain the step we had to take to answer our research question. Is users' following behavior on Instagram a predictor for the personal attributes? We start with collecting the data and then look for patterns in our dataset to finally run the statistical analysis with this data. First, we have to get the data we will later need to run our statistical analysis. In Germany, Instagram has developed to be the second most popular social media platform among millennials after WhatsApp, and prior research is scarce. This is the main reason we use the platform as source of our data. The first step is to define accounts, which are the core of our analysis. We will try to find patterns among users following these accounts and investigate whether these can predict certain user attributes. After screening different German Instagram accounts, we derive a set of 215 accounts. Specifically, we try to make our account selection as diverse as possible, so we will be able to predict different user attributes. Second, we scrape 20 to 30,000 random followers for each of the 215 accounts. Therefore, we arrive at an initial sample population of 4.3 million unique users in our dataset. In this graph, we see that most users in our dataset follow only one of the previous selected accounts. However, to identify patterns in users' following behavior, they need to follow several accounts. Thus, users who follow just a few accounts are excluded. Since the quantity of users diminishes with the number of followings, we decide to include users with 4 or more followings to ensure our dataset remains large enough. This results in a reduced sample size of 112,549 users. The next step is to scrape the profile metadata for each user, as we need this information to extract attributes of the users that we scraped beforehand. Specifically for each user, we retrieve the username, the number of posts, the number of followers, number of followings, full name, biography and captions, as well as information on whether they have a business account, a private profile, and if the user joined recently. We use this information to exclude private profiles because they miss necessary information for the analysis. Additionally, we exclude users who follow more than 1,000 accounts in total because they are likely to be fake profiles fishing for followers. Including them in the analysis would result in noise in our data, making it difficult to detect patterns. At last, we scrape the user's followings to complete our dataset. After eliminating business profiles, this yields a final sample of 12,530 users. With this data, we create a user-like matrix where users are represented in rows and the accounts to follow are depicted in columns. Following a respective account is coded with a value of 1 and the counter event is coded with a 0. Next, we aim to identify patterns within the following behavior of users, such that users following account A are also prone to follow account B. So let's see if we are able to uncover patterns by using hierarchical clustering, more specifically by Watt's method. Therefore, we transpose the initial matrix and use the users as segmentation variables. The first cluster we identify contains sophisticated news and information sources, such as Tagesschau or die FAZ. Another cluster encloses political parties from the left wing, such as Die Linke or Die Grünen and the Fridays for Future movement, which is represented by Luisa Neubauer and the official account of Fridays for Future. A third cluster that we extract considers accounts that are concerned with beauty and fashion topics. They are promoted by female influencers such as Kamushka or Yvonne Ferrer. In conclusion, we are able to extract meaningful clusters so that users actually have some kind of patterns in their followings. Which brings us to the next question. Since there is indeed a pattern in the following behavior, is it also possible to reduce the complexity of our user-like matrix? At this point, the matrix contains 215 individual accounts. These will serve as our independent variables in the statistical analysis. Of course, this would result in a very complex structure that needs to be analyzed. Thus, we aim to reduce the complexity by applying singular value decomposition, or short SVD. SVD is the matrix decomposition method that enables us to display a large amount of variance of the original matrix by a very compressed one. Explaining the mathematical procedure would go beyond the scope of this presentation. But if you're interested, we are happy to answer your questions at the end of the presentation. After applying SVD to our user-like matrix, we're able to display 60% of the total variance by reducing the 215 accounts to 20 components. This makes it a lot easier in the interpretation of results. Here you can see all 20 components and how we labeled them. We know it's a lot, but imagine we would still deal with the 215 accounts. These components represent topics such as female or male entertainment, well-established YouTubers, news and politics, or Twitch streamers. We know you're very curious about how we exactly came up with those labels. To explain this, it's easiest to show you the procedure with the help of an example. In order to find the most important accounts for each component, we take a look at the component loadings of each account. These reflect the correlation between the respective account and the component. Accordingly, a high positive loading indicates that the account is important for the component. For the final labeling, we inspect 3 criteria based on the component loadings. First, we inspect the accounts with the highest loading for each component. Therefore, we sort the loading sizes in descending order for each component and plot it against the number of accounts. By doing so, we identify the most influential accounts for each component. In this example, these are Capital Bra, Shirin David, and Unge. The elbow, which you can see in the plot, serves as a reference point, as it means a sharp drop of the loading size. Second, we also take a look at the accounts on the right side of the elbow to make sure that additional information provided by these accounts is not lost. In our example, these accounts are Pietro Lombardi and Mero428. As a final criterion, we can take a look at the highest component loadings for each individual account to make sure that each of the accounts is assigned to at least one component. As you see in this example, Capital Bra, Shirin David, and Miro confirm the results of the other criteria. Additionally, Bushido seems to fit the composition. Nevertheless, accounts such as plant-based food and travel seem rather unrelated. This might be due to the low following number of those accounts, and therefore these are not considered for our labeling. Finally, as you may have already guessed, we label this component German rep. We aim to use the found components to predict user attributes. But so far, we don't know anything about the users except whom they are following. Therefore, we first need to identify and extract relevant user attributes from the profile metadata. As a starting point, we analyze the textual data we scraped, that is the user's biographies and captions. We clean the text and simply count words. Eventually, we produce word clouds like this one. Here we identify terms that seem to be related content-wise to each other, like years, like city names, and terms that could be hobbies or interests, or even relationship status. Additionally, we check attributes that were analyzed in prior research, like the study conducted by Kosinski and colleagues. But why can we do all that? Well, users deliberately share lots of personal information in their profiles, as shown in these examples. One attribute that is interesting for us, and has been in prior research as well, is the user's age. Unfortunately, users express their age in many different ways, providing their actual current age, their year of birth, or their exact birthday. Hence, to capture all expressions, we derive several regular expressions covering the various forms. Additionally, there are users expressing their age in written out numbers. To derive the age from them, we use a dictionary with these terms and their numerical representations. Eventually, we derive the user's age directly or calculate it with 2020 as a reference year. Applying this method to all users' biographies, we extract an age for circa 1500 users in the dataset, ranging from 10 to 75. The density plot here clearly shows that especially users below 20 years tend to provide their age in their profiles. After deriving the user's age, we build a linear regression model with the components as independent variables and the age as the dependent variable. We see that the model is significant. The Pearson correlation coefficient is 0.556, which indicates a moderate fit between actual and predicted values. We find the component female influencers for beauty and fashion to have the strongest negative influence on the age, whereas female lifestyle influencers in news sites show the strongest positive influence on the age prediction. In the graph, you see this relationship between component 3, which is female lifestyle influencers and news sites, and age. You might ask yourself what else your following behavior reveals. Well, looking at the examples mentioned earlier, we find hints to other personal information like relationship status. Unlike for age, we cannot simply build regular expressions to identify those users. We rather inspect several profiles and research typical terms and hashtags for the relationship status as single, married, and in relationship in order to build bilingual dictionaries. Additionally, we find that some users like to use emoticons instead of words. Therefore, we identify these emoticons and include them into the dictionaries. We then check for every term in the biography if it matches a term in the dictionaries. If we find no matches in a user's biography, we proceed to check the captions and match them with the dictionaries. In this example, we know that the user is married, as she uses the term Ehemann. After matching the dictionaries with the biographies and captions, we find 971 users that indicate a relationship status. About 1/4 of them is single, 31% are married, and the rest is in a relationship. We now use this data to build a logistic regression model to distinguish between users that are single and those that are not. We built an overall significant model that has good predictive power with an area under the curve of 0.753. We find the component news and politics is the strongest indicator for being single, whereas the component female lifestyle influencers in news sites indicates being in a relationship. This graph shows the receiver operating characteristic curve, indicating that our prediction based on the following behavior is clearly better than random guess. So we then developed several dictionaries to derive other attributes like gender, if users support the LGBTQ+ community, where they live, or what their hobbies are. We use linear and logistic regressions to derive and predict 21 user attributes. Eventually, we get good prediction results for almost all of them. The variable residence, so meaning whether a user lives in a big city or in a certain part of Germany, is not predictable by user following behavior. Additionally, the linear regressions for the number of followers, number of posts, yield only poor results, but our logistic regression models concerning more personal information, for example gender, or if a user is a parent, can be predicted with high accuracy. What implications can we derive from the selected data and from our prediction models? We will learn that we can predict even sensible attributes like sexual orientation. But first things first. We find some distinct patterns among our models, showing that following accounts, which belong to any of the three components, female lifestyle influencers in news sites, TV celebrities, and female influencers for beauty and fashion, indicate that you are likely to have children, are probably female, comparably older, and in a relationship. Whereas following accounts such as Heute Show or Faktastisch, loading highly on the components news and politics and entertainment and sports, indicating that you are probably childless, male, comparably younger, and single. The component female lifestyle influencers in news sites influences the likelihood to be classified to be a vegan or a vegetarian, whereas entertainment and sports rather indicate that you prefer a beef burger over a veggie one. As being said, we even predict sensitive attributes such as sexual orientation. And even if the subsample was relatively small for this model, we find significant results for supporting the LGBTQ+ community. Following TV celebs such as Oliver Pocher or Daniela Katzenberger indicate that the user might be not hetero. The opposite accounts for following Twitch streamers such as Knossi. From a marketeer's perspective, hobbies of potential customers are a piece of valuable information. Following accounts such as Kamushka or Faktastisch of the component female lifestyle influencers in news sites, or following the component YouTubers in entertainment, strongly indicates that you are interested in fashion and beauty. And again, following the component entertainment and sports, as well as following YouTubers and TV personalities, is indicating that you love soccer. These entertainment and sports guys, no wonder they are single, eating meat and watching soccer all day. You may wonder why you should care about this. You should, seriously. As harmless and funny this information might be at first sight, it is likely that this publicly available data is harvested someday and used to target or intimidate you. If using this kind of data helped Donald Trump to become president, or as Christopher Wiley, a former data analyst at Cambridge Analytica puts it, data is morally neutral. I can take a knife and hand it to a chef to make an amazing meal or murder someone with it. The tool is morally neutral, it's the application that matters. There are three main groups that may use your personal data for their own purposes. First, there are cybercriminals. Identity theft is not yet a big topic here in Germany, but we can see what happens every day in the US right now, where in 2019 14.4 million consumers became victims of identity fraud. Can you imagine that a third of the US population already experienced some kinds of identity fraud to this day? Secondly, there are companies that may use your data to place customized ads and content, pretending to appear randomly. Social media providers know where you live, where you go every day, where you like to travel, what you click, watch, and eat, so simply everything. And this data is priceless. When have you received your last paycheck for giving away so much personal information? The US election of 2016 has unmistakably shown how powerful sensible data is. Cambridge Analytica has built a complete personalized social media ad ecosystem over years to slowly get into voters' heads and strengthen the alt-right movement and candidate Donald Trump. Your following behavior makes you a perfect target for commercial as well as political campaigns. Please carefully watch the content you will see in the upcoming elections in September. Lastly, there is the government and linked authorities. Nothing to worry about in good old Germany, right? For sure, the BND is not the secret service you should worry about compared to other digital capacities other countries have. We all remember the NSA scandal of 2013. Right now, China is the living Big Brother state. The introduction of the social credit system made every Chinese citizen vulnerable to the violation of almost all civil rights that we in the West consider as self-evident. But privacy breaches are a Chinese issue, you might say. No, it isn't. The European Court of Justice reviewed the Vorratsdatenspeicherung in Germany and did forbid it, but with letting enough leeway for all European governments. And maybe you've heard about the Schufa. If you applied for a loan before, being the German gatekeeper for getting a mortgage or starting off your own business, and have you received an offer for a free fitness tracker by your public health insurance yet? Be aware, Big Brother is watching you. Thank you very much, and most importantly, follow us on Instagram.